I want us to look at questions where graphs are drawn and we are just interpreting the graphs. Like in this example here, f of x and g of x are drawn. And we want to find, first of all, the values of a and b. We will start with a. A, take note, is in the function of f, and that is the sine graph. And in this diagram, this here is our sine graph. It will help you to remember the basic graph for y is equal to sine of x. Remember, it will look something like this, where that is 0 degrees there, and there is 90 degrees there, and so on. Now, if you look at this point, 0, 0, and you look at this point, minus 30 degrees, 0, you can tell that there was some shifting from 0, 0 up to negative 30 degrees, 0. And so if you want, you could say 0 degrees and 0 was actually shifted to negative 30 degrees and 0, and take it from there. Now this is clearly a shift to the left, and it is a shift of 30 degrees to the left, which tells us that in our question here, the value of a should be equal to negative 30 degrees. Now, the reason why a should be negative 30 degrees is because if we sub in that negative 30 degrees into our function there, we will get x plus 30 degrees. Remember, we said when you see a plus, it means you are shifting to the left. Now we will find b. And b is in the graph of g, which is that graph there, and that is the cosine graph. Again, the starting point would be for you to just remind yourself about the basic cosine graph. It looks like that, where that is 0 degrees there, and that is 90 degrees there, and so on. Now, because we are looking for b, which is the coefficient of x, we need to make use of the period of the graph. We said the period of cosine x will be 360 degrees. Did you know that that period can be divided into four quarters? This is the first quarter of the period. And this is the second quarter there up to the turning point. And that would be the third quarter there up to the x-axis. And that there would be the other quarter. So this is 360 degrees altogether. But now if you divide it into quarters, you know that a shape like this will give you 90 degrees here. That part is another 90 degrees. The other part is 90 degrees. And the other one there is 90 degrees. And that makes the 360 degrees. So the period of cosine x is 360 degrees. Now let's look at the given graph here and try and work out the period. Now you will notice that starting from negative 30 degrees up to here, that gives us half of the period. And at this point here, because of symmetry, we know that x must be equal to 30 degrees. So from negative 30 degrees up to 30 degrees is half of a period. And negative 30 degrees up to 30 degrees gives us a total of 60 degrees. So 60 degrees is actually half of the period. and this will tell you what the period is. If 60 degrees is half of the period, then a complete period should be 120 degrees. But there is a formula that we use for finding period. The period is always given by 360 degrees divided by the coefficient of x, which in this case is b. That is what we use to get period. But we know in this case that that period is 120 degrees. So if we solve this equation, we should get b is equal to 3. Now we want to determine the coordinates of point A, B, C, and D. I would like us to start with point A. In this case, notice that we can look at the point negative 30 here up to that point. This one here will be 30 degrees. And so we are saying there is a gap between minus 30 degrees and 30 degrees of 60 degrees. So similarly, you can use that same argument and argue that between point A and this negative 30 degrees, there is a gap of 60 degrees. So if you move 60 degrees to the left of negative 30 degrees, you should end up at A. Therefore, your point A should be at negative 90 degrees and 0. What about point B? So if this is 30 degrees here, it means we need to add 60 degrees to get this point here. So we know that at that point, x should be equal to 90 degrees. But we are looking for point B. And point B should be midway. And so to get point B, you can just take the 30 and the 90, add them up together, and divide the answer by 2. So it's 30 degrees plus 90 degrees, all that divided by 2. The y coordinates, because this is the cosine of bx, it obviously means the range, because the coefficient of cosine bx there is a 1. So the range is from negative 1 up to 1, which means at point B, the value of y should be equal to negative 1. So if you simplify that, you should get b equals 60 degrees, negative 1. Now what about point C? You can use the cosine graph to find point C. Remember we said this is 30 degrees and we're jumping in 60s to get to this point, so that one is 90 degrees. We need to jump another 60, and so at C we will end up at 150 degrees. Therefore C should be 150 degrees and 0. And finally D. For D, it will help us to take note that point D is the y-intercept, which means at point D, we know that x is equal to 0, but that point D also lies on the graph of f of x, which means it lies on y equals sine of x minus a, but we know a now, so that is sine of x plus 30 degrees. So you can just substitute there to get y. So if you substitute, you should get y is equal to sine of 30 degrees, but sine of 30 degrees should be equal to half, and that will help us find D. Therefore, point D, at point D, x is 0 degrees, but y is 1 over 2. This one here says find the period of G. I think we worked that one earlier on. And then we want to look for the range of the function h given that that function h is equal to negative f of x plus 1. You can rewrite that. That means function of h will be equal to negative f of x, but we know f of x. F of x is sine of x plus 30 degrees. All that plus 1. So this graph must be reflected along the x-axis. That is what the minus sign is telling us. But if you reflect it along the x-axis, the range will still remain as negative 1 and 1. And so the range of h should be all values of y. Now we need to just add this 1 here to each one of those values of y. And so we'll get minus 1 plus 1, and then 1 plus 1. And so y should be an element of 0 up to 2. Number 5, we are explaining how the graph of g should be transformed in order to get this new graph here. So first of all, remember the graph of g is given by cosine of 3x. And we are trying to change that or transform that into another graph which is given as cosine of 3x minus 30 degrees, all that plus 2. Right, what you need to do here is to factorize the 3. You see 3 is common, so take it outside the bracket there, and you'll get x minus 10 degrees inside, plus 2. Now x minus 10, there's a minus there. That tells us that the graph of cosine of 3x should be shifted 10 units to the right. So to describe the transformation that took place here, this should be a shift 10 degrees to the right. The plus 2 is also a shift 2 units up.